The percent dissociation of chlorous acid in water is 8% when its concentration is 1.58 molar. What is the pH of the solution? So percent dissociation is equal to the concentration of H plus over the initial concentration of the solution times 100%. First, you want to convert the 8% into a decimal. So 8% is equal to 0.08. So that's just 8% divided by 100 to give you 0.08. So the percent dissociation will be equal to 0.08 equal to the concentration of H plus over the concentration of the solution, which was 1.58 as given in the problem. And then in order to find the concentration of H plus, we'll just multiply these two values. 0.08 times 1.58, which gives you a value of 0.1264 molar. So in order to find the pH, which we know is equal to the negative log of H plus, we'll just input the value that we calculated earlier, which is here. So it'll be equal to negative log of 0.1264, which will be equal to 0.89. Now, using the same question, we're going to find the Ka value for this acid. So we know that the Ka, or the equilibrium constant, for the acid is going to be H plus ClO2 minus over HClO2. So the dissociation of this weak acid can be written as HClO2 will give you H plus ClO2 minus. So because we're dealing with the dissociation of a weak acid, we have to write out the ice table. So the initial concentration of the acid is 1.58 molar. We'll put negative X here to distinguish the change in concentration. And that will give us an expression at equilibrium of 1.58 minus X, where the initial concentration of H plus and ClO2 minus will be 0. Put positive X to illustrate the gain in products, and that'll give us an equilibrium of X. So now we can input these values, or these constants, into the Ka value that we calculated before. So Ka will be equal to X times X over 1.58 minus X. So from work calculated in problem A, we found that the concentration of H plus was equal to 0.13 molar, which is equal to X. And we can just sub in the value of X into the equilibrium expression. So Ka will be equal to 0.13 times 0.13 over 1.58 minus 0.13. And this will give you a Ka value of 1.1 times 10 to the negative 2. And that's your final answer.